In this video, we are going to find all integers x and y such that x squared minus y squared all squared equals 16y plus 1. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. My first observation on this equation is that I can ignore all the cases when x and y are negative numbers. The first reason is that notice the left side is a perfect squared, so that means it's non-negative, which means 16y plus 1 is non-negative. So y is at least minus 1 over 16, and since y is an integer, this implies y is never a negative number. The second reason is that even when x is a negative number, I can always find, say, for this case, if I had a negative number, say minus n, where n is positive, something like that, then I can simply remove the minus sign and I will still get another pair of solution. So that means as long as I focus on the cases when x and y are non-negative, then I can always generate the remaining solution pairs when x might be negative. So afterwards, I'm going to take a look what would happen when x or y is equal to 0. If y equals 0, then x all to the power 4 equals 1. So that means x is either plus or minus 1. If x equals 0, then that means y to the power 4 minus 16y minus 1 equals 0. But there is no integer solutions. So what remains are the positive cases. Notice that I can write x squared minus y squared all squared. On one hand, it equals to x plus y times x minus y all squared, and at the same time I can say that this is larger than or equal to 2 times x plus y times x minus y all squared. This is because x and y, each of them, is larger than or equal to 1. So the sum is at least 2. And of course this is equal to 16y plus 1. So therefore, I can say that 2 times x minus y all squared is less than or equal to 16y plus 1 over 2 times, sorry, not 2 here, that should be x plus y. But at the same time, this is clearly smaller than 16y plus 16x over x plus y, and that's 16. So that means x minus y all squared is less than 8. And since x and y are integers, that means x minus y all squared should be equal to 0, 1, or 4. However, if x minus y all squared equals 0, that means x equals y. So for our original equation, the left side equals 0. So there's no solution for that. We can reject it. And what remains is x minus y all squared equals 1 or 4. Another thing is that 16y plus 1 at the right side of our original equation is odd. That means x squared minus y squared all squared, and hence x squared minus y squared is also odd. So since x squared minus y squared is a multiple of x minus y. So x minus y odd. And we can also reject this case as well. The case when x squared equals 4. So we only have to check what happens when x minus y all squared equals 1. So therefore, x minus y is either equal to 1 or x minus y equals minus 1. Now let's see what happens when we have this difference. When x minus y equals 1, then x squared minus y squared equals y plus 1 all squared minus y squared, and that's 2y plus 1. So therefore, 2y plus 1 all squared equals 16y plus 1. And we can simplify this equation. And so y equals 0 or 3. And then x would equal to 1 or 4. Then of course, I can also have minus 1, minus 4 here. Now back to the other case. When the difference is now minus 1, that means y is the larger integer. Then x squared minus y squared equals minus 2y plus 1. So therefore, minus 2y plus 1 all squared equals 16y plus 1. Then 4y squared minus 20y equals 0. So y equals 0 or 5. Then x would equal to minus 1 or 4. Then of course, we can also remove the minus sign or add the minus sign and take x equals 1 or minus 4. So altogether, we have these solutions. 1, 0, minus 1, 0, 4, 3, minus 4, 3, and then 4, 5, finally minus 4, 5. Altogether, 6 solution pairs. So this is the final answer. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.